right, I see questions or comments in the chat from Colin. Says let's see. So from Colin says, what are the minimum sufficient observations needed and what are the ideal set of observations? And this is open up to questions. You can also raise your hand if you prefer to go live, and we can unmute you if you can't unmute yourself.
So James, I'll go with that for just a minute. It's not clear whether we're talking about observations to feed a simulation, or observations for something else. So I'll just take the to feed a simulation. One of the reasons why this concept of ensembles is so important and so valuable is because if we're thinking about something that's going to go on tomorrow, next week, or next year, we don't know exactly the conditions. And so being able to feed it the range of conditions that we anticipate and looking at the sensitivity, understanding where those thresholds in behavior might be, where those cutoff points, where we might need to think about contingency planning within the broad range of conditions is important. So again, the inputs here are going to be, wind fields, and it's possible to put in a shift in winds, right? It doesn't have to be a constant wind during the burn. It can be a shift. Again, somebody has to understand that might be a possibility and include that in their ensemble. But then the range of fuel conditions, for instance, Kevin talked a lot about fuel moisture, for instance. So having that range allows us to get away from the fact that we have to have exactly knowledge of what the burn conditions will be.
Yeah, great response there. Russ, I see you've got a question in the chat. It says, please elaborate on the significance of your access to and use of FIA/tree list data.
Yeah, that's a great question from Colin Hardy there. The tree map product, which was developed by Karen Riley at the Fire Sciences Lab in Missoula, is a really critical component in fast fuels. So if you're not familiar with that product, basically Karen has a partnership with the Forest Service FIA that gives her access to their data, and she has built a imputed map that links plot IDs back to the landscape. So it's a many-to-one type, they're one-to-many type relationship, where an individual plot from the FIA database is imputed back to multiple landscape locations with the idea that you're getting a representative forest for that area. And that is a really critical part of our fast fuels because importantly, tree map is wall to wall. So while the underlying FIA data are plot data that are used to assess forest health and inventory at the national scale, the tree map product is a scale crossing measure that enables you to represent forests out there with, driven by real data, but it's not the real data for that particular location. So that's where our on-ramps, such as the True Trees process that Ilkay was talking about in the Wildfire Burn Pro 3D framework, is really critical because what it enables you to do is for those many, many large areas where we don't have LiDAR data or other very detailed data yet, Fast Fuels provides default synthetic data driven by FIA, leveraging the tree map that Karen Riley put together. But where we have LiDAR data, we can bring that in and we can update or replace the trees and Fast Fuels with that data. So we're envisioning actually multiple on-ramps by which these fuels maps could be updated. So these include both airborne LiDAR, high resolution imagery, Nick talked about the terrestrial LiDAR scanning, which is critical for understanding the ladder fuels. It's really the best data you can get for characterizing that. And then additionally, we've been working with collecting data using drones, UAS, uncrewed aerial systems. That enables you at a project scale to collect 3D data for a prescribed burn area. It's possible within not very much time to use a drone to map your fuels in 3D. So that's something that we're hoping that the Forest Service will expand the capability and access to that technology. But fundamentally, with fast fuels, we're trying to have a system that makes it easy to connect things. So we want to be able to use any data out there that's good for mapping fuels. We also want to connect to any fire model that's out there. So our goal is to make it easy for all these things to come together. So I don't know if I answered your question, Colin.
Yeah.
Russ, can you talk to a little bit about some of the known weaknesses with respect to like shrub and grass fuels and how you're hoping these multiple on-ramps kind of help us get past that?
Sure. Yeah. So the interesting thing is, like, each individual way of assessing fuels data has its own strengths and weaknesses, right? Like, we're all used to Brown's transects, and what it does is count sticks and give us an idea of loads, particularly of the ones, tenths, and hundreds and things like that, right? It sure doesn't capture the 3D structure. And that's why things like TLS that Nick was showing us are so powerful. Similarly, airborne LiDAR captures tree tops, but is not as strong on the understory trees or on surface fuels. And I think where we're headed is that what we want to do is leverage all of the data we can for any given location. So if we have LiDAR, if we have high resolution imagery, we ought to be developing a way to bring all that in. And the strategy that we've been putting together with fast fuels is that we're going to have multiple on-ramps for different sources, and then different people can contribute to expanding those as kind of modules. So what we want to do is have a model in which, different researchers could come up with different ways to use TLS data, for example, or different ways to use drone data. What we want is put the best of everything together, and really there's some substantial synergies when you start comparing and combining data sources that we're already starting to see. I see a hand up there from Kevin.
Go ahead, Kevin.
Oh,
You're muted.
I didn't mean to interrupt you, Russ. That's why I put my hand up.
Well, I saw that hand go up and I was like, dang, I guess Kevin's got a question. Go ahead, though.
Now, one of the real neat opportunities, I think, is to involve managers in this process. And Ilkay didn't spend a lot of time on the AI, but one of the efforts that we're trying to push towards, and this may appeal to some folks and they may want to be involved in this way moving forward, is what is safe and unsafe. If you run these ensembles and we allow for fire, say, to sneak across the line in ways that it does, how much fire would a manager need, and you got to look at these ensemble runs individually to say that's too much, that's unsafe, or that's marginal, or if I had a big crew, I might be able to hold that line. And really, we've been working with her AI team and some managers to actually put their brains and their preferences into artificial intelligence code that can then scrape through any ensemble and say, this represents unsafe 80% of the time. And that ability to maybe start capturing some of the more, or the less objective part of objectives, safety is a pretty difficult thing to quantify, I think, is a neat part of what Ilkay, and I know you popped up here, so feel free to jump in, is doing with her team, and it will require expert opinion in a variety of ecosystems to get right. And so as we develop, if folks want to be just put their brain into the computer, there will be opportunities to establish workshops and engage with you in that way, and to be able to try to quantify risk.
Yeah, and I would just add to that, and of course the pre-recorded introduction was totally botched due to the bandwidth issues, but really at the foundation and the bottom line of what I was trying to get across there was that this co-production and involvement with managers has been critical in the product that Kevin just demonstrated. It started a number of years ago, at Eglin Air Force Base and Tall Timbers through some collaborative research burns. And, what's discovered is kind of as Joe O'Brien had in his talk, it's complex. They're, statistically verifying or, validating these models is extremely difficult because you've got so many, what I would call sliding scales of things that change during, and, manager input is absolutely critical to making sure that we get this right. And so, there has been manager input, not only from, Kevin and I, but from a number of other managers, Brett Williams at Eglin Air Force Base, as well as other managers at Tall Timbers, the folks with the Forest Service at the Hitchty National Forest and the Osceola National Forest. But more is better with regard to getting managers involved, especially those that have kind of that internal slide deck of a lot of different prescribed fire scenarios in a specific fuel type, where you've really got that deep smarts that can be applied and kind of plugged in and run through the AI and machine learning that Ilkay and her team there with the Wi-Fi Commons are doing. So, manager input, I guess, bottom line, for co-production just continues to be really critical to making sure that this product is the best that it can be. So with that, I'll open it up. Okay, I see some things coming in the chat here.
Maybe I can also respond to some of the questions or comments in the chat because AI came up.
Yep, great.
So I think we have a role in terms of how AI can be used in a couple of different places. Here as a community, we can bring together, as Kevin said and Ross said, many data sources to come up with the reality of a place as we knew the best known facts kind of thing for a place in time. So we can go back and forth and access data from different moments in time through these data systems, so that we can actually learn from burns that we continue to demonstrate. And as there are models and LiDAR data and better forms of field data is becoming available. And I think the important thing to recognize is we are also trying to do some demo burns. So we have a demonstration network that is diverse both in landscapes and the type of demographics the burns are reaching. And through that, I think there is an opportunity to measure, validate, and you can add measurement capabilities before and after or during burns to address some of the comments in terms of effectivity and verification. And to become a better user is possible. I see one comment there in the context of those demo burns. So we'd like to actually work with burn sites in particular to bring in new users and look for
can I add to that?
Yes.
So I think as for the beta users, one of the things that we've learned in recent times is the value of having numerous different users with different styles for the way they like to do their burns, but also different landscapes. The generality that we would like to expect from models like this can only be tested by putting it on different kinds of landscapes with different kinds of topography and different kinds of vegetation. So I think that's absolutely critical, is to pick up breadth that way.
Yeah, great comments. Yeah, and some great commentary going on in the chat as well. And Kevin, did you want to expound a little bit on your the comment to Colin? I think that's a great point you're making there.
Well, I mean, I think that it's up to burn bosses too on the call to chime in. I mean, how you, Colin's asking essentially, how do you communicate risk to the public? I mean, we don't really do that well, and to be able to look at leverage some of these AI tools and simple rules tools to help maybe capture burn boss preference or that integrated knowledge that you accumulate over years of experience, and to be able to use that as the training data for AI to look at these ensembles, or maybe even show the public this is low risk or this is high risk, or show a burn boss that you're on the edge of what most people would do. What are you going to then do to maybe mitigate those expected higher risks? And I was saying, I mean, that adjustment of risk tolerance should be a parameter that a burn boss or burn planner can move up and down. If you had a wildfire downwind that had previously burned all the fuels up, now my risk tolerance goes way up. And again, the AI should help us to be able to capture risk, communicate what goes into it, and then help burn bosses potentially contribute to our understanding of risk, and then maybe place them in the in that sliding scale of risk tolerance relative to the community at large.
One of the things that we've learned about trying to set this up for AI is how do we leverage the burn boss knowledge, which Kevin already talked about, but also how do we come up with quantitative metrics that the AI can interpret and associate with those things that are put in by knowledgeable burn bosses. So the development of metrics that kind of capture what a burn boss might be concerned about, as far as escape, for instance. Those are things that can only come through the interaction with burn bosses, as they articulate what are they watching for, and what are they concerned about, and what can their holding crews assess, because those criteria need to be assimilated into what the AI is learning from.
Yeah, great points. And one thing, a point that I don't want to be lost, and Russ touched on it in his presentation, is the potential as a training tool and a communications tool for the public. And we're talking about communicating risk to the public. Just think about, you've got wildland urban interface setting with public lands with a heavy fuel buildup, high risk of wildfire, using Burn Pro 3D or Quickfire for that matter. You could do a visual representation of what happens with a wildfire in that area, and then do a visual representation of a prescribed fire in that area, and present some really powerful training tools for public outreach, and hopefully gaining acceptance for the the nuisance and the inconvenience that comes from smoke from a prescribed fire. If you could actually visualize, whether it's through those VR goggles or just via the video presentation, the latest models presenting the risk without prescribed fire or mechanical fuels reduction versus doing those things and showing the difference, I think could just be a really, really powerful use of these next generation models. Oh yeah, Ilkay, great comment, and that was really neat. The ideas that you came up with the students trying to or working on these different communication tools. I didn't know if you wanted to spend just a minute covering that. It was really neat.
This was definitely a learning experience, and we'd like to do more of these design challenges. Last year, based on our advisory board and the comments from them on public acceptance of prescribed burns, we ran a design challenge with UC San Diego students, and we had 140 students work with us, and 33 of them came up with 7 teams who won the challenge, at least the ideation part of it. So over the summer, we worked with them on creating experiences using these high resolution data and science-based tools. And some of them are virtual reality experiences. You walk through the landscapes, and we call them immersive forests. And sometimes you can also decide what kind of burn you'd like to do and what's the effect of a higher intensity, low intensity fire type of experiences, both in games. We worked with Kevin and others on like burn bus as the job title. How do you communicate the burn bus's role? And that, I think, has been really effective in terms of engaging with some burn buses. And we also have created, board games, and Cool of California is a physical installation built for parks to explain fire behavior. And we even have a little dog called Sparky. We later learned Sparky is already taken as a term or a name, so we'll change the name. But I can put that video. I think it's a cute one. I can put that video in the chat.
Yeah, and technically we were supposed to finish at 12 noon Central Time, but I'm certainly willing to stay on. There's some great questions coming up in the chat. I see Ray's question, and I agree with what he's saying about, conditions change throughout the course of the day, and the firing patterns will change throughout the day as needed. Those are great points. Looking for the question. Okay, the question is, Ray, did you want to come up live? Can you unmute yourself, and maybe we can get some conversation, because I think you make some great points here, and we've got the right people here to answer it.
Well, can you hear me okay?
Yep, got you loud and clear.
All right. As a burn planner, which is primarily how I make a living, and then also as an instructor, I'm trying to envision how to use Burn Pro and incorporate that into my fire behavior documentation and developing my prescription. Currently, I envision multiple scenarios that might occur, and then document that through Behave and put that in my plan. And so I'm picturing how I would do that with Burn Pro. Knowing, and I say in the burn plan, as is in the Behave manual, the fire predictions coming out of the Behave program are very limited. And so I capture that in my burn plans and say that, 50% of managing the fire behavior to meet objectives is up to the burn boss and the firing boss and how they manage fire in that environment. And is Burn Pro going to take us another step further in that and remove some of that subjectivity? I'm just trying to figure out how to incorporate this product into a burn plan, and is it more real time? Is I heard a rumor this might involve a smartphone carrying in your pocket. You take little snapshots as you're during implementation. Do I quell that rumor? So does that give you enough information what I'm thinking about?
Yeah, I think that's some great points. And Ray, what it sounds like to me is it'd be fantastic to have you providing input to this team, because obviously as a fire planner, you're coming in with a really important viewpoint and background information that I think could really help guide this, so that it does provide the information that you would need for your documentation. But I'm not sure if anyone else wants to take a stab at answering that question.
I can chat if everybody else is willing to let me chat. So at this moment, we're not on smartphones or moving at that speed yet. But I think that kind of vision and that kind of ambition is what drives these kinds of technologies to find the right venue. So that kind of input is absolutely critical to keep pushing things in the right direction. So, but going back to your question, I think right now, at least in my mind, one of the ways that you help with that real-time decision-making that you articulated, which is so important to the success of a burn, is allowing fire managers to explore ahead of time the range of scenarios that they might be seeing. And in fact, you could put in a range of shifting conditions if you kind of expect, oh, the winds might change during my burn, et cetera, so that you can develop ideas about what those contingency plans might look like or what might be necessary, and communicate those to the team is one way where I see you're helping a planner or a burn boss think ahead, but that's different than the real-time decision making that you were previously talking about. Kevin, thoughts?
I think that the planning tool itself should be pretty helpful. Being able to create the ensembles quickly is what BurnPro 3D is designed to do. Interpreting them, saving them, making them into the burn plan as part of that ignition plan component, if you're doing 21 element plans, is kind of what we designed that persona around. It should also cover your ignition plan piece as well. I mean, at the end of the day, Ray, I think that we're to this point where we're asking for help. If you were interested in being part of a beta team, and Casey volunteered in the chat, talk with us about how some of the Fish and Wildlife Service help, which has been tremendous so far from that agency. We really want users to engage now, and while we've got resources and capacity to make adjustments, and finding how best to make this useful is that co-production piece that James started with. So it's not going to solve world peace, but it should be a useful tool. And as you get closer to the burn day, we might change personas in that burn boss. Instead of running 1,000 ensembles, it takes a weekend, they might run 3 or 4 based on the predicted weather tomorrow, and that may take an hour. And hopefully, as we get y'all involved, really thinking about these personas more deeply and how people should use a tool or shouldn't will be more readily apparent.
All right, and I see, Rod, there's a question for you in the chat. It says conventional fire models predict compatibility or predict probability of torching based on wind speed, height to live crown base, etc. It seems like quickfire and the like should do a better job than Rothermel-based models at predicting torching. Is there any evidence of it? You're muted, Rod.
Thank you, James. I have to do that at least once a meeting, or it's not me. So quickfire determines whether or not you're drying and causing fire within a canopy, for instance, based on energy transfer and energy movement from one space to another, like ground fuels up to crown and or crown to crown. It's all dynamic and not preset in its abilities to, it's not predetermined whether this output, this intensity will crown or not. It's based on the wind speed and the conditions and whether or not you're in drafting from the side. I think Kevin's got an example of the crown streets that came out of the example that Nick showed earlier. And what's really encouraging about this particular example that Kevin has up is that the model is capturing those crown fire patterns and behaviors that we're seeing in the real case based on the fire progression in combination with the dynamic wind speeds of the time. So you've got a shifting wind speed interacting with the dynamic fire, which creates those kinds of patterns. So it's just an example of where we're hoping it will go. And and so we're hoping to get that generality where your crown fire behavior is more dependent on the local fire activity, which includes ignition patterns, right? As well as the ambient fire environment.
Yep, I see. Ilkay, you have your hand up.
Yeah, I had a comment on the earlier point of generating burn plan documentation. I think the current user experience is designed on the burn planning for prescription generation, and decisions made by burn bosses can be exported into a burn plan. But as a vision for the future, where we'd like to see the Burn Pro 3D develop into is definitely make that part even better as a user experience and more integrated, but also as a collaboration tool between the agencies running these burns or executing these burns, and more into logistics and excuse me, logistics, and also the adaptive burn type of scenarios where data and strategies are generated. So an obvious place for us to start was the pre-planning of a burn and creating data points for a burn plan. But I think in the future, we'll look for partners to expand this into other stages of burn management in a science-driven way.
Yeah, thanks. Okay. See a great couple of questions from Tobin Smale asking about how does 3D fuels represent or differentiate vegetation that burns more easily, such as shrub types like chaparral, from others that do not burn with the same fire behavior, or in terms of trees where conifers torch and crown more easily than deciduous trees, and how is spotting represented in the fire simulation models? So maybe not sure if Russ or Kevin, there are several parts of that question if somebody wants to jump in, because I don't know the answer.
Russ and Rod.
Russ and Rod. All right.
Go ahead and start, Russ. Or not.
Sorry, I was totally distracted writing another email, as we all do when we're all in meetings.
For shame.
I've missed the question.
All right, it's in the chat. How does 3D fuels represent or differentiate vegetation that burns more easily versus that doesn't, like conifers versus hardwoods, or shrub species like chaparral? Is that teased out in 3D fuels?
Yeah, so great question. At the heart of it, the strength of the data that we have right now is primarily on the forestry data. So one of the things we're working on doing is developing on-ramps that improve our ability to describe finer detailed characteristics of shrubs and grass and things like that. Those are kind of a little bit in process or progress, but so there's a series of variables that are tracked in the voxels. So you have fuel density, fuel moisture, a surface area to volume type measure. At present, it's mostly about fuel loading differences between species. That is, the main driver there. But we are leveraging values from the literature for some of the other parameters. And I think, yeah, we basically, one of the strengths of this system is that we can, because we're working with tree level data, if we have trees that are, let's say, drought stressed, we could have them have lower fuel moistures. We're currently working with a couple teams that would be building connector models following this kind of Lego block model connection concept that would enable live fuel moistures, for example, to be driven by weather data and site parameters, things like that. But yeah, there's a whole world of characterizing the surface fuels and shrubs and things like that that we're just starting to enter into. And I think we have the capability to represent tremendous variability and detail. Like you could have a tree in which part of it is affected by some pathogen and has a high, higher flammability due to lower moisture or whatever. But right now we're just kind of building the basic connections, and I think there's a lot of the upside of that finer detail, particularly on the surface fuels, that's going to be coming in, coming up. Let me hand it over to Rod.
So I think Russ certainly hit on the easiest pieces of the puzzle, which are already built in, and that is the, moisture, fuel moisture gradients between both live to dead, of course, but within live, the fact that you're representing your vegetation in 3-dimensional voxels at meter scales means that you can have all kinds of different moisture patterns within trees. If you've got some pathogen, for instance, or between trees, etc. The other things that we have the ability to pull in are things like surface area per unit volume, which is one of the big differences between some species and other species, is when you've got those really fine small leaves that are very rapidly convectively heated or cooled. Those have a different burn characteristic than other types of vegetation. And the other one that's possible right now, we don't bring it in as an input because we don't have the data to support the gradients. But for instance, heat of combustion. If there's data to support that one species has a different heat of combustion than another species, there's no reason that can't be read in as an input. We just don't have the widespread data to feed it right now. So right now we're using a sort of a baseline value that's representative of a broad range of species. So yes, you could as we, again, going back to Ilkay's data needs, as we get better data and better kinds of inputs, the models can always be tailored to bring those in. And because the models are in principle being developed on those basic building blocks, you can add in that additional sensitivity without a whole lot of trouble. They're already built into the model. We just don't have the data to manipulate them right now.
Yeah. Appreciate that. And I noticed we're about 17 minutes past the hour, and I'd like to kind of wrap things up by first off thanking all of the presenters today. I mean, I think even with the technical difficulties that we've had with some of the bandwidth issues, presentations were great. I know it takes time to put that together. I think the interaction's been great. Appreciate all the input from the folks that have been active in the chat. I also want to thank the training team within Region 9. That's Dave Ducart and Brian Hicks and Amanda Jones, who helped in the background to make this happen. But again, thanks everyone. We'll go ahead and close it out there. These presentations will be posted in the Wildland Fire Learning Portal. And if you need information on how to access the presentations, just you can contact me or the training team at Region 9. So with that, we'll go ahead and close. I hope everybody has a great rest of the day.